What if I told you that some of the largest machines ever built are designed for one impossible mission, moving thousands of tons of steel and concrete to create a path where nature never allowed one to exist? Every bridge you cross hides a world of giant cranes, floating platforms, robotic systems, and engineering machines working with millimeter precision. But here's what nobody tells you. Building a bridge is not just about placing steel in the sky. It is a battle against gravity, weather, pressure, and time. Imagine standing below a suspension bridge under construction. Above you, thousands of tons of steel cables stretch across the sky. Around you, machines roar, cranes rotate slowly, hydraulic systems push enormous loads, and concrete pumps send material hundreds of meters upward. The surprising truth is that some modern bridge components are manufactured thousands of kilometers away before they ever reach the construction site. So how does this incredible journey begin? Before the first pillar touches the ground, engineers already know the forces this bridge must survive. Some bridges are designed to handle earthquakes, hurricane winds, millions of vehicles, and even temperature changes that make steel expand and contract every single day. And this is where it gets truly extraordinary. Every bolt, cable, and machine has a hidden story that begins long before construction starts. The journey of a bridge begins deep inside the earth. The steel that forms the skeleton of massive bridges starts as iron ore, often extracted from huge mines in countries like Australia, Brazil, and China. In open-pit mines, enormous haul trucks carrying more than 300 tons per load move through landscapes carved away by giant excavators. The raw ore may contain around 60 to 70% iron, but it must travel through crushing, separating, and refining processes before it becomes the high-strength steel engineers depend on. After extraction, the ore travels through powerful crushers that break massive rocks into smaller pieces. Inside processing plants, magnetic separators remove unwanted materials, and furnaces transform the concentrated iron into usable metal. The temperatures inside steel production can exceed 1,600 degrees Celsius, hotter than volcanic lava, while chemical reactions remove impurities and create a stronger material. Most people never think about this, but the steel inside a bridge may have passed through fire, pressure, and thousands of kilometers of transportation before construction even begins. But steel is only one part of the story. A bridge also depends on concrete, and concrete begins with limestone, clay, and minerals extracted from massive quarries. Limestone can travel hundreds of kilometers to cement plants where it is heated near 1,450 degrees Celsius inside giant rotating kilns. This process creates clinker, the key ingredient that gives concrete its incredible strength. The strange thing is that one of humanity's oldest materials is still one of the most important foundations of the most advanced bridges on Earth. Once steel and concrete are ready, the next challenge is transportation. A single bridge beam can weigh hundreds of tons and stretch longer than a passenger airplane. Specialized trucks, ships, and rail systems move these enormous components across continents. Some pieces travel over 10,000 kilometers before arriving at the construction site. But moving the material is only the beginning. The real challenge is turning thousands of separate pieces into one structure that can survive for a century. Now the real transformation begins. At the construction site, thousands of individual parts arrive like pieces of a giant puzzle, but this puzzle weighs millions of kilograms and must survive forces that never stop. Before anything is lifted into place, engineers inspect every beam, cable, and concrete element using precise measurements. A bridge is not built by simply putting pieces together. It is created through a carefully controlled sequence where every second matters. The first major step is foundation construction. Giant drilling machines cut deep into the ground, sometimes reaching more than 50 meters below the surface to find stable rock. These machines rotate enormous drill heads at controlled speeds, creating deep shafts while removing soil and rock. Inside these foundations, steel reinforcement cages are lowered and surrounded by concrete poured through specialized pumps. The concrete can arrive at temperatures around 20 degrees Celsius to 30 degrees Celsius, but chemical reactions inside slowly transform it into a rock-like structure capable of carrying enormous loads. After the foundations harden, the bridge towers begin to rise. Huge cranes lift prefabricated steel sections weighing hundreds of tons into position. Some cranes can lift more than 1,000 tons, moving slowly at only a few centimeters per second because one small mistake could damage millions of dollars of equipment. Workers communicate through radios as the metal structures move through the air, surrounded by wind, vibration, and the constant sound of machinery. But here's what makes bridge construction truly fascinating. The steel pieces are not simply placed together. They are connected through advanced welding, bolting, and tension systems designed to handle extreme forces. Robotic welding machines can operate at temperatures above 1,500 degrees Celsius, creating joints strong enough to survive decades of stress. The smell of hot metal fills the air as sparks fly, turning raw steel sections into one continuous structure. For suspension bridges, one of the most incredible steps is installing the main cables. Thousands of individual steel wires are pulled across the bridge using specialized machines with extreme tension control. Each cable may carry thousands of tons of force, and workers monitor every adjustment with sensors measuring movement down to tiny fractions of a millimeter. What happens next surprised even experienced engineers. The entire bridge begins to behave like a living system, moving slightly with wind and temperature changes. Concrete deck installation comes next, and this process requires perfect timing. Large sections are positioned using cranes, while specialized concrete machines spread material evenly across the bridge surface. Concrete curing can take days or even weeks depending on the design, and engineers carefully control temperature and moisture to prevent cracks. A bridge may look finished from the outside, but deep inside, millions of chemical reactions are still strengthening the structure. Then comes the final assembly stage, where every section must connect perfectly. Engineers use hydraulic systems capable of generating thousands of psi to adjust heavy components into exact positions. A difference of only a few millimeters can create problems years later. And this is where the hidden world of bridge construction becomes clear. The biggest structures on Earth are completed through the smallest details. But before thousands of vehicles ever cross this bridge, engineers must answer one final question. Can this giant structure survive forces stronger than anything an average day will ever bring? The answer comes from a world of artificial storms, powerful machines, and technology designed to push the bridge beyond its limits. Before a bridge opens to the public, it enters a world where machines, computers, and human expertise work together. Modern bridge construction uses technologies that would look like science fiction just a few decades ago. Robots inspect welds, drones scan massive structures from the air, and artificial intelligence searches for tiny defects invisible to the human eye. But here's what nobody tells you. The strongest bridge is not the one built fastest. It is the one tested beyond what anyone expects. One of the most important tools in modern bridge engineering is laser scanning. High-precision scanners capture millions of measurement points to create a digital copy of the entire structure. These systems can detect movement, deformation, or alignment problems as small as a few millimeters. Imagine a machine looking at a bridge the way a doctor examines the human body, searching for the smallest warning signs before they become serious problems. Inside manufacturing facilities, robotic systems create many of the steel components used in bridges. CNC cutting machines slice giant steel plates with extreme accuracy, often maintaining tolerances within fractions of a millimeter. Automated welding robots repeat thousands of perfect movements, controlling heat and speed to create consistent joints. The machines never get tired, but there is still one thing they cannot replace: the experience of a skilled engineer who knows when something does not look right. Quality control begins long before the bridge reaches the construction site. Steel samples are pulled from production lines and tested inside laboratories using powerful machines that stretch, compress, and twist materials until they fail. Some tests apply forces measured in thousands of kilonewtons, revealing exactly how much stress the material can handle. Engineers study these failures because understanding the breaking point is how they create structures that rarely break. After construction, the entire bridge faces even larger tests. Engineers simulate powerful winds, heavy traffic loads, vibrations, and temperature changes. Large hydraulic systems push and pull sections of the bridge while hundreds of sensors record every reaction. Some bridges are tested with loads heavier than normal traffic because engineers want to discover every possible weakness before people ever cross. Modern bridges also depend on thousands of smart sensors hidden inside the structure. These sensors measure vibration, temperature, movement, and stress every second of the day. Some systems can send automatic alerts when unusual changes appear, allowing engineers to investigate before problems grow. The bridge is no longer just steel and concrete, it has become a giant machine that can communicate. But even with all this technology, there is a moment where human skill still wins. During final inspections, experienced engineers walk through the structure listening, watching, and feeling details that machines may overlook. A strange vibration, an unusual sound, or a tiny visual change can reveal something important. After decades of innovation, the human eye remains one of the most powerful tools in bridge construction. And now comes the moment that decides everything. After years of planning, millions of components, and countless hours of testing, the bridge must prove it belongs among the world's greatest engineering achievements. But when we look beyond one bridge, the numbers reveal something even more surprising: an entire global industry built around connecting the planet. The largest bridge projects can require tens of thousands of tons of steel and hundreds of thousands of cubic meters of concrete. Some mega bridges cost several billion US and take more than a decade from planning to completion. Countries like China, the United States, Japan, India, and Germany lead many of the world's major bridge engineering projects because of their enormous transportation networks and advanced construction technology. China has built some of the world's most impressive bridge networks, including thousands of large highway and railway bridges. The country's rapid infrastructure growth has pushed construction technology forward, using advanced prefabrication systems, automated equipment, and massive lifting machines. The United States continues to focus on repairing and modernizing aging bridge systems, while Japan has become famous for earthquake-resistant designs that allow bridges to move safely during powerful seismic events. Think about this: some of the world's longest bridges stretch for more than 100 kilometers, crossing huge distances that once separated communities. These structures require thousands of workers, advanced machines, and constant maintenance throughout their lifetime. A bridge is never truly finished after opening day. It continues to live, move, and require care for generations. Did you know some modern bridges are designed to last more than 100 years? Engineers use special coatings, corrosion-resistant materials, and smart monitoring systems to protect them from rain, salt, wind, and temperature changes. Did you know that a single bridge cable can contain thousands of individual steel wires working together like a giant metal rope? And did you know that some bridge foundations are built deeper than a 15-story building is tall? Over the last 50 years, bridge construction has completely changed. Older bridges depended heavily on manual labor and traditional methods, but today's projects combine robotics, artificial intelligence, digital twins, and automated machines. Engineers can now simulate entire bridges inside computers before construction begins, predicting how they will behave decades into the future. The next generation of bridges will not only carry vehicles, they may collect energy, communicate with transportation systems, and repair themselves. In the next 10 years, experts expect bridge construction to become even more automated and sustainable. More recycled steel, lower carbon concrete, robotic construction systems, and AI-powered inspections will reshape how bridges are designed and built. But no matter how advanced technology becomes, one thing will never change: every bridge begins with a simple human idea, connecting one place to another. From mountains to oceans, bridges have become symbols of human imagination and determination. They rise above impossible landscapes, survive powerful forces, and carry millions of people every day. But behind every giant structure is a hidden world of minds, factories, machines, engineers, and workers who make the impossible possible. And now, we return to where the journey started: the raw materials, the machines, and the people who create these incredible connections. A bridge may look like a simple path across water or land, but now you know the truth. Inside every beam, every cable, and every concrete foundation is a story of fire, pressure, precision, and human creativity. What appears to be a silent structure is actually the result of one of the most complex manufacturing journeys on Earth. Think about this the next time you cross a bridge. Thousands of tons of material once existed as rock beneath the ground. Machines transformed it, workers shaped it, engineers tested it, and technology protected it. And this is where it gets truly extraordinary. Something built from the earth became a structure that allows humanity to move forward. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.